Hello student, very good morning. Today I am delivering the lecture that is about the types of mixtures here. So this is of your chapter second, that is matter around us pure here. So first we must know what you mean by pure, and then we have the impure. So today we have the topic of mixtures. So mixtures is generally considered to be act as a impure matter here. So this is what we have in this. So we have to go with what you mean by that is mixtures here. And the types of mixtures we have, there are two category of mixtures, that is homogeneous mixture as well as the heterogeneous mixtures here. So as we see in here, what we find that this is a mixture, we have homogeneous as well as heterogeneous mixture. Homogeneous mixtures means where the composition of the two component are same throughout the mixtures here. But in case of heterogeneous, the composition of the component that is irregular here. So this shows the irregularity of one component and the second component, and this shows the regular distribution of the component. So on the basis of this one here, we can classify or categorize that is mixture into two part, that is homogeneous as well as the heterogeneous mixtures है. So it means कि mixture क्या होगा हमारे पास, it is a composition of two or more component here whose ratio are not be fixed here. When the ratio of the substances here in a solution here does not fix here, that is called as a mixture here. It is a type of the solution here, or you can say it is a type of the compound when the two or more substances, they do not have the same composition, and when they do not have the same composition, then they form the mixtures, and mixtures are further classified as heterogeneous as well as the homogeneous here. So this is what we have. Now what do you mean by homogeneous mixture? So homogeneous mixture, when we add sugar, butter and lemon juice together, they are uniformly mixed together here. So how we can say कि इस केस में हमारे पास जो distribution है वो uniform है, because when we take a sip of this type of mixture here, what we find that each and every sip of this butter have a similar taste here, from the very first to the last one here, until unless we have to dissolve it clearly here. Now, and second one is, when we prepare this type of mixture, we cannot separate this one here. So if we cannot separate these mixtures here, that is lemon juice, sugar, butter and salt from this one here, this shows that in this case the distribution of the component in the mixture, in the solution, is continuous here or uniform here, and because of this uniform distribution, this gives rise to formation of a homogeneous mixture. Homo means that is same or uniform, same or uniform here. Genus means phases है, so they have the uniform distribution. The ratio of the composition of the homogeneous mixture can be different here. The ratio may be different. For example, we have the glass of butter and a spoon of sugar here, and half or pinch of salt here, and a half spoon of that is lemon juice here. So their composition are totally different here. That's why they are considered to be mixtures. If the composition remains same here, then they may not be altered. It is a mixture here. Okay? For example, one may add 2 spoons of sugar in lemonade, while someone else may add only 1 spoon of sugar in their lemonade. Still, lemonade is a homogeneous mixture. So this shows the different composition of it same time of mixture, that is the lemonade here. Okay, now next we have, that is, what do you mean by heterogeneous mixture? So in case of heterogeneous mixture, what we have, the component in heterogeneous is not completely dissolved in each other, and which can be separate by physical here, by just filtration. हम filter करेंगे तो इसको हम निकाल सकते हैं. For example, what type of heterogeneous mixture we have? For example, in case of we mix sand in water here or clay in वाटर है, हम अगर मिट्टी डालें या रेत डाल दें पानी के अंदर, तो उस तरह के सॉल्यूशंस को हम क्या कहते हैं, heterogeneous mixture. तो at that case what happens, if we dissolve it continuously, after certain time what we find that कि most of the that is sand and clay here, they are settled down here, and if we filter it by using a piece of cloth or a filter paper here, what we find that कि whole of the material here, जितने भी आपने सल्यूट पानी के अंदर डाला है, जो सैंड और आपके क्ले है, वो सारी की सारी क्या होगी, क्लॉथ के ऊपर या फिल्टर पेपर के ऊपर आ जाएगी. तो इट मीन्स दिस कैन बी सेपरेट वेरी इजीली हेयर, बट इन केस ऑफ होमोजीनियस वी कैन नॉट सेपरेट इट हेयर. ठीक. सो दिस इज now, in this, what we find that there are three different types of solutions. We have true solution, colloidal solution, as well as the suspension here. So these three different types of solution can be classified or simply explained on the basis of, you can say, their particle size here. In case of true solution, what we say that the particle size is less than 10 raised power minus 7 centimeter here. Whereas in case of colloidal solution, the particle size is between 10 raised power minus 7 to the 10 raised power minus 5 centimeter here. Now in case of suspension here, the particle size is greater than that, is 10 raised power minus 7 centimeter here. So on the basis of this one here, we can classify or define three different type of solution here. Now तो यहाँ पे आप क्या देख रहे हैं, what we find that generally की जो particle का size है एक ट्रू सॉल्यूशन के अंदर, जो हमने पहले भी पढ़ा हुआ है, तो वो बड़ा छोटा है हमारे पास. लेकिन जैसे जैसे हमारे पास सॉल्यूशन की टाइप चेंज होती जाएगी, तो व्हाट वी फाइंड दैट द पार्टिकल साइज गेट इंक्रीजेज है. सो व्हेन द पार्टिकल साइज गेट इंक्रीजेज है, we get three different type of solutions here. And first solution is considered to be homogeneous mixture, and the other two one are called as a heterogeneous mixture here. Because heterogeneous mixture, the particle size are bigger than that of the true solution here. Now next we have that is how we differentiate between the homogeneous and heterogeneous mixture. So homogeneous and heterogeneous mixture, these are called as solutions, these are called as suspension and colloids. Substances uniformly distributed, unevenly distributed, visible to the naked eyes but visible through the microscope. This can be visible through the naked eyes, also through the microscope. The particles appear smaller in size, but they are somewhat larger than that of the particles of the homogeneous mixture. So homogeneous mixture is a true solution, and heterogeneous mixtures can consist of colloidal as well as a suspension here. Now further, now what is suspension here? So here what we see, this is a just example of, you can say, that is suspension. Here what we take, we have a that is chalk powder as well as a detergent which are mixed in the butter here. So when detergent and chalk powder are dissolved in butter, this gives rise to a suspension here. What do you mean by suspension? A suspension is formed when two or more substances are mixed in a non-uniform manner here. ठीक है. तो heterogeneous mixtures are generally a suspension also है. The fluid does not mix with the solvent and can be viewed with the naked eyes है. तो अगर चाक पाउडर को आप पानी में डालेंगे तो उसको आप हिलाते रहेंगे, वो कभी भी डिजॉल्व नहीं होगा. ठीक है, वो कभी भी डिजॉल्व नहीं है. चाहे आप इसको जो आपके डिटर्जेंट है इसकी अमाउंट बढ़ा दें, तो पानी में अगर आप दिखा लेंगे तो व्हाट वी फाइंड दैट कि ये कंप्लीटली डिजॉल्व नहीं होगा आपके पास. तो आफ्टर सम टाइम व्हाट वी फाइंड दैट कि मोस्ट ऑफ द सब्सटेंसेस जो हमने एक सॉल्वेंट के अंदर डाले हैं, एक तो वो मिक्स नहीं है और दूसरा वो क्या हो रहे हैं, दे आर सेटल down. Okay, so this shows that this is a suspension here. So this is the example of the suspension. Now we have further, that is the classification or property of the suspension. Suspension is also having example of this. Most of the pharmaceutical suspension, जितनी भी आप medicines जो आप लोग खाते हैं, mostly जो sugar सिरप्स होते हैं, ठीक है, उनको हम सभी को क्या कहते हैं, सस्पेंशन कहते हैं. जैसे खांसी की दवाई आप मोस्टली लेते हैं, तो वो हमारे पास क्या होता है, दिस इज ए सस्पेंशन है. नो, व्हाट आर द प्रॉपर्टीज ऑफ सस्पेंशन? फर्स्ट ऑफ ऑल, इट इज ए होमोजेनियस मिक्सचर्स. It can be seen through the naked eye. We can see the path of the light through the suspension, that is called as Tyndall effect. The particle of suspension tends to settle down but left in dust अनडिस्टर्ब्ड है. तो अगर हम उसको कुछ देर के लिए रख देंगे तो वो क्या हो जाएंगे, नीचे बैठ जाएंगे. देन दे कैन बी सेपरेटेड बाय फिजिकल मेथड, बाय सिंपल फिल्ट्रेशन प्रोसेस है. तो हम इसको क्या कर सकते हैं, सेपरेट कर. तो दिस इज हाउ व्हाट वी हैव द प्रॉपर्टीज ऑफ द सस्पेंशन, एंड दिस इज व्हाट वी हैव कि हाउ वी कैन कॉमनली इलुस्ट्रेट कि व्हाट यू मीन बाय द सस्पेंशन। तो जितनी भी आपके पास पीने की दवाई होती है, मोस्टली जो खांसी के टाइम हम यूज़ करते हैं, वो हमारे पास क्या सस्पेंशंस हैं, ठीक है। नेक्स्ट हमारे पास है व्हाट आर कोलाइड्स आर कोलाइडल सॉल्यूशन। दिस इज आल्सो ए heterogeneous mixtures are solution in nature. The particle cannot be seen through the naked eyes. No, they are colloidal of type Tyndall effect. They do not settle down if undisturbed. They can be, the particle can be filtered through the filter paper here. A centrifuge to separate the particles of a colloid here. तो heterogeneous केस में जो हमारे पास colloidal mixtures है, इसकी हमारे पास थोड़ी सी डिफरेंट प्रॉपर्टी एज वेल एज द सस्पेंशन है, क्योंकि जो इसकी एग्जांपल हम ले लेते हैं। नाउ when we proceed further here, what we find out, there is some example of this colloidal solution like milk, foam, fog, detergent, then we have blood, paint, cosmetic. तो ये सारी की सारी जो हमारे पास examples हैं, these are the example of the, you can say, colloid here. So what we find in this case here, in case of milk, fog and this detergent, cosmetic, paints, तो अगर हम इसको कुछ देर के लिए रख भी दें, लेट अस सपोज हमने क्या किया, मिल्क को आधे 2 घंटे के लिए रख दिया, और एक तरफ हमने क्या लिया, heterogeneous mixture sand and clay. What we find that after some time the clay will settle down, but the milk के अंदर जो क्रीम है, it never be settle down here. The fats of the milk never be settled down. It remains distributed evenly in the solution here. This is what we have the differentiate between colloids as well as the suspension here. The example of suspension we have here, that is milk, fog, smoke, detergent, paint, blood. Then we have the cosmetics here. Okay. Now next we have, this is the properties of, you can see, the colloidals, where we find that this is a solution, this is colloid, and this is suspension here. When we pass through light through this one here, we find a clear path of the light through the colloidal as well as the suspension. Suspension में भी थोड़ी सी डिस्ट्रीब्यूशन हो सकती है, लेकिन आपके पास colloidal के अंदर कोई भी डिस्ट्रीब्यूशन नहीं है. Similarly, what we observe in case of room are in a, you can say, जैसे विंडो से लाइट आती है तो आपको क्या दिखता है, क्लियर स्ट्रीक दिखती है, और उसके अंदर पार्टिकल मूव करते हैं, और वो जो पार्टिकल्स होते हैं, दे आर कॉल्ड एज कोलाइडल पार्टिकल्स है, एंड जो लाइट आएगी दैट इज बिकॉज ऑफ दैट पार्टिकल. एंड सिमिलरली व्हेन वी सी थ्रू द बुशेस ऑफ प्लांट हेयर, कि वहाँ से जो स्ट्रीक ऑफ लाइट होती है, दैट इज आल्सो ए, दैट इज टाइप ऑफ द you can say Tyndall effect है. तो this Tyndall effect is generally shown by the colloidal particles as well as the suspension particle. But in case of solution, you cannot see this here because the solution is considered to be a clear, transparent here. Now, what do you mean by this one here? This is a Tyndall effect here. The light which pass through the colloidal particles as well as suspension, as we see through the window as well as the bush, you can say trees here in the winter season, but mostly we see. So this effect is called as the Tyndall effect here. Now, what is Tyndall effect here? Tyndall effect is the when a beam of light is passed through the colloidal particles. Okay, the scattering of the light take place here, and because of the scattering of the light, we see the path of the light in the solution here, and this light is mostly with the help of this colloidal particles. If the colloidal particles are not there, we cannot see the you can say visible the light. For example, when a ray of light enters a dark room, it's scattered by the dust particles here. That means dust particle क्या हो जाएंगे आपके पास, colloidal particle या फिर suspension in the air, and we can see the path of light clearly here. So this is what we have, the what you mean by the Tyndall effect here. That is, Tyndall effect is when a beam of light is passed through a colloidal particles of the colloidal, scatter the beam of light, and we can see the path of light in the solution here. Now next we have, that is another property which we observe in case of the colloidal solution, that is the Bronnian movement. So कहता है कि Bronnian movement क्या है, कहता है कि जब लाइट हमारे पास पास करते हैं तो हम क्या देखते हैं, जहाँ फिर हम इस केस में कि जब हम देखते हैं कि जनरली जो हमारे पास लाइट है, ठीक है, वो यहाँ से बाहर आ रही है, ठीक है, जब खिड़की में देखते हैं या यहाँ से देखते हैं तो आप क्या देखते हो, उसमें पार्टिकल फ्लोट कर रहे हैं. पार्टिकल क्या करते हैं, फ्लोट करते हैं। कहता है जो फ्लोट मूवमेंट होती है उसकी, ठीक है, वो जो मूवमेंट होती है दैट इज कॉल्ड एज द ब्रोनियन मूवमेंट है। और ब्रोनियन मूवमेंट जो हमारे पास उसके अंदर होगी दैट इज जिगजैग मोशन ऑफ द colloidal particles है। तो that means when colloidal particles are so well observed in a microscope, they get scattered or moving in a zigzag motion here. So because of this zigzag motion here, this is called as a Brownian movement. As the light is scattered by colloidal particle, these particles execute ceaseless as well as erratic random motion here, and that ceaseless erratic zigzag motion is called as the Brownian movement, and it is due to because of the collision of the particles with each other. तो यहाँ पे आप क्या देख रहे हो, एक पार्टिकल दूसरे पार्टिकल के साथ जब कोलाइड होगा तो एक तरह से वो जिगजैग पाथ को अटेन करेगा और उसको हम कहते हैं दैट इज ब्रोनियन मूवमेंट। एंड इट इज ड्यू टू द बॉम्बार्डमेंट ऑफ कोलाइडल पार्टिकल्स बाय द मॉलिक्यूल ऑफ द डिस्पर्शन मीडियम। जहाँ तो वो अपने साथ कोलाइड करेगा या हमारे पास जिसके अंदर हमने उसको डिजॉल्व किया हुआ है उसके साथ ये क्या करेगा, कोलिजन करेगा और अपनी डायरेक्शन को चेंज करता जाएगा। ठीक है। Now next we have classification of colloid. Colloids can be classified into two part. For example, in case of solution, we have two part, that is solute and solvent here. But in case of colloidal solution here, we cannot explain in the form of you can say solute and solvent. Here we have the dispersed phase as well as the dispersion medium here. The dispersed phase particle are the solute like component in a कोलाइडल के। डिस्पर्स पार्टिकल क्या है हमारे पास, एक सोल्यूट लाइक कंपोनेंट है, और डिस्पर्शन मीडियम क्या है, एक सॉल्वेंट लाइक मीडियम है। ठीक है। सो दिस इज हियर वी हैव द सॉल्वेंट लाइक मीडियम के, नॉट द सोल्यूट लाइक, इट इज ए सॉल्वेंट लाइक पार्टिकल्स एडेड है। तो डिस्पर्सिंग मीडियम एज वेल एज द डिस्पर्स्ड फेज है। ठीक। नाउ डिपेंडिंग अपॉन द डिस्पर्स्ड फेज एंड द डिस्पर्सिंग मीडियम वी हैव द डिफरेंट टाइप ऑफ द colloidal solution. So we have solid liquid gas, solid liquid and liquid solid here. So on the basis if we see here the dispersing medium which is a solvent here, liquid and solid here, we can classify different here. If liquid is the dispersed phase and gas is the dispersing medium, we get aerosol here. So air is a gas and liquid is a droplet here. तो droplet means humidity here. तो हम क्या कहें, fog, clouds or mist here. तो because we know that liquid is nothing, it is a water here. तो वाटर के अंदर जो वाटर है वो गैस के अंदर जब आएगा तो हमारे पास क्या बन जाता है, fog, cloud और mist. तो we know that जब हम सर्दियों में fog से निकलते हैं या सुबह स्कूटी से निकलते हैं, सैर करने निकलते हो, आप देखते हो कि आपकी जो जैकेट है, स्वेटर है, उसके ऊपर वाटर ड्रॉपलेट आ जाते हैं, और वो जो वाटर ड्रॉपलेट है that is a liquid here. So what we observe, this is a liquid which is water, it is act as a dispersed phase, and dispersing medium is a gas here, in which it means gas is a solvent and liquid is a solute here. So on the basis of this one we can classify it as a aerosol, and example is fog, cloud and mist here. And solid particle in gas, again it is aerosol. because why it is called aerosol, क्योंकि इसमें जो लार्जर कंपोनेंट है वो कौन सा आपका डिस्पर्सिंग मीडियम है। एंड देन सॉलिड के केस में स्मोक, ऑटोमोबाइल एग्जॉस्ट, डस्ट पार्टिकल इन एयर, दिस इज अनदर एग्जांपल ऑफ दिस वन है। गैस लिक्विड, अगेन फोम, गैस लिक्विड। अब गैस जो है आप देखते हो जब आप जाग बनाते हो किसी के साथ, जैसे आप डिटर्जेंट डालें या कोई भी चीज़ डालें, उससे जब जाग बनती है तो वो क्या है, इट इज़ ए बबल्स ऑफ गैस है। तो bubbles of gas present in liquid, we get a foam here, and it is mostly from the shaving cream, liquid emulsion, that is make face cream here. तो liquid जब emulsions होती हैं, they are emulsions है। जो milk का हमारे पास, it is not a solution, it is a colloidal solution. What type of colloidal solution? It is a emulsion. So it can be prepared here by mixing you can say fat in water here. तो फैट और वाटर को जब हम स्ट्रांगली मिक्स करेंगे बाय यूजिंग इमल्सिफाइंग एजेंट हेयर एंड बाय इमल्सिफायर यू कैन से मशीन हेयर, दिस लीड्स टू फॉर्मेशन ऑफ ए मिल्क एज फेस क्रीम. तो सॉलिड एंड लिक्विड अगेन सोल्यूशन मिल्क ऑफ मैग्नीशियम मड, गैस सॉलिड फोम अगेन स्पॉन्ज प्यूमिका, लिक्विड सॉलिड जेल जेली चीज़ एंड बटर है. तो जेली जो हम खाते हैं टॉफ़ी चीज़ और बटर दे आर ए जेल के, वो हमारे पास क्या है, जेल है। तो लिक्विड और सॉलिड क्या है, सॉलिड हमारे पास डिस्पर्सिव मीडियम और थोड़ा सा पानी और ज़्यादा सॉलिड, जिससे ये बनता है। एंड सॉलिड सॉलिड नोड और सोल वी हैव कलर्ड जेम स्टोन है। तो जो जेम स्टोन्स होते हैं हमारे पास, जब मिल्की ग्लास होते हैं, वो हमारे पास एक तरह का कोलाइडल सॉल्यूशन है, और उसमें दोनों में हमारे पास क्या होते हैं, सॉलिड सॉलिड है। ठीक है स्टूडेंट, होप सो यू अंडरस्टैंड that is type of this you can say mixtures, and they are homogeneous and heterogeneous, and further homogeneous and heterogeneous are classified. Heterogeneous are classified as a that is this suspension as well as a colloidal solution. Yeah. Hopes you understand all the topic of this types of solution. So thanks for this one here to uh, stay with me. So stay home, stay safe, and happy learning. All the very best. Okay, bye bye.